We'll let it be. We'll talk about it after lunch. Okay, how's that? There you go. All right. Section 3/8 is your last section before you have your test. Okay, and what we want to talk about is higher order derivatives. Okay, and when I say higher order derivatives, what I mean is you guys want to be able to understand first derivatives, but also second, third, fourth, so on and so forth. This has applicability because if you have a position function, you guys remember we covered this in section 3-4. What is the derivative of the position function? It is the, starts with V, velocity function. The derivative of the velocity function happens to be the acceleration function. So there is applicability here, especially when you get to a calculus-based physics course. So we want to understand those derivatives. Let's look at the first example. Here's the notation that I'm familiar with. It says examine the functions below, determine which function is f, f prime, f double prime, f triple prime. After 3, I often see this notation, a 4 and a 5. We don't quite have that many up here. We can cross that one off, but we want to identify which is which, okay? And I know that you guys don't have color, so let's just call this G for green, P for purple, B for blue, R for red, and Y for yellow. All right. So, kind of where to get started. I think the best way to get started is to look at the first two, F and F prime. Can you look up here at the graph and try to identify which one might be F and which one might be F prime? Picking those out is, what's that? G and Y. I would say G and Y are related. That one could be a derivative, one could be, the derivative of it. But one of these is the original function. So Luke, why did you say R and B? Okay, thank you. First of all, what's the slope right there? And what's the value of the red graph at that spot? So that's one indication. The other one is this. This blue graph has an endpoint here, and we don't take the derivative at that spot. If you look, all the others are undefined at 0, where blue is not. So blue is going to be our original. That's going to be F. And as Luke has pointed out, the derivative of the blue is equal to 0 here, and the function that's red has a value of 0 at that spot. So this is F prime. Because if that's my original function, it has a slope of 0, and this crosses 0 at that spot. Now, maybe you thought, well, maybe the blue is a derivative and it crosses 0. No other function has a slope of 0 at this spot to match up with. So you really know that the blue one is going to be the original, and then the red one is the first derivative. So now we think about this, okay? Let's look at the red function. Slope, positive or negative? Very, very positive. Very good. Is it ever 0? Is it? Okay, so Bo sees here that they have to be positive the whole time, and it's only G and P there above the x-axis the entire time. So we know it's either G or P, so we have to decide what to choose from there, okay? A method that somebody chose last hour, which was a good one, is they looked at the slope right here at 1, 1. They decided what appears to be about that slope? About 1, and if you look at G, G has a value of 1 at that spot. Whereas P has a value that's higher, a slope of around, say, 2 or 3. So G would be the correct choice in this situation for that derivative. You should be able to do this, yes. G is equal to F double prime. Now we go to P. I'm sorry. Now we look at G. So if you want to take the derivative of G, positive or negative? Negative. So it's always negative, so that means it's below the x-axis. So this yellow graph is the derivative of G. So this would be F triple prime. Yes. You mean uh, okay, I understand what you're saying, and that's a good observation. I don't think you would use that in the case of most graphs to identify the original and the derivative. So I would encourage you to consider where the derivative is positive, where it's negative, where it's zero. Those are the most important parts. And then finally, if you look at the last one, y here, is the derivative positive or negative? Positive, 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 all the way across. So therefore, it must be either g or p, because those are the ones that stay above the whole time. And p is the only one left. But if you look at it at 1 right here, okay, just if you look at this slope right here, you can tell that it's greater than the other slope that we have, um, than the red one. And so it's going to be this purple graph. It has a larger value at that spot than the green one does. So that's our f fourth derivative. So I know that that's not easy. You're going to have to look at the graphs in your book, and you got to kind of struggle through them and figure them out. I would encourage you to consider first by looking at, where it's equal to 0. Yes. What I looked at was where any of these graphs cross the x-axis. Only the red one and the blue one cross the x-axis. That means that they would symbolize that there's a derivative equal to 0 somewhere. Okay? Only one of these can be the original, correct? Only one can be the original. Well, both the red one and the blue one cross through 0. So that means one of them has to show that there's a derivative equal to 0. Which graph up here has a derivative equal to 0? Only the blue one. Well, then you would have to use some other processes of elimination as well. Do you see that blue is the only one that has a derivative equal to 0? So if you draw a tangent line on any of these graphs, this is the only one that you could draw where it has a slope of 0. And you can see that the red function has a value of 0 at that spot. So that means that the red is the derivative of the blue. I would hope that as you're going through the process, yes, that you would be able to say, well, the derivative is equal to 0 there, and the function is as a positive slope all the way, so it should be above the x-axis. Those type of reasonings we should be able to think through. In your book, I can't remember if it asks you to justify your answer or not, but if I ask on the test or study guide, why is G, and you've been asked this question before, why is G a good representation of the derivative of y? You would say, well, because y always has a positive slope, and G is always above the x-axis. Now, G isn't actually the derivative of that, but it would be a reasonable guess. Be a reasonable guess. Okay? So, a little confusing, but you got to be able to think it through. Let's try something that's a little easier here, okay? So, it says find the first and second derivatives of the following functions. So for a, we have f of x is x to the fourth minus 4x squared plus 2x minus 1. We simply want to find f prime of x and f double prime of x. What's f prime? Now to find f double prime, you simply take the derivative of the derivative, and you get? Good. That's it. Okay? What do you have to use to find the derivative for b? The chain rule. Just the chain rule. So derivative of the inside, 2 times derivative of the outside, 5u, which is 2x minus 3 to the fourth. So 10 times 2x minus 3 to the fourth. So we didn't set up the boxes. I hope you can all do it without the boxes. If you can't, and you feel more comfortable on the test, then go ahead and set up the boxes. What's the inside? What's the outside? Derivative 10u to the fourth. And derivative 2x minus 3, 2. Multiply them, we get 80. U, which is 2x minus 3 to the third power. That's it. Not too bad, huh? Okay, let's try a little bit more difficult problem. Given f of x is sine of x, find the 402nd derivative of sine of x. Okay, what do you see? So there should be some type of, yeah, yep. So let's just start off here. I'm just going to use a number to represent the derivative so that we can keep track of what we're doing. What is the first derivative of sine of x? What's the second derivative? Third? A cosine? Fourth? Sine of x. So the fourth derivative gave us the original function. If we take the fifth derivative, it would be what? Cosine, which is the same as the first. So this is the fifth derivative. So this will be the sixth. This will be the seventh. This will be the eighth. So I really would hate to write all those numbers out all the way up to 402. 4, 8, all divisible by 4. So what's a number close to 402 is divisible by 4? 400. So would you agree that the 400th derivative is going to be sine of x? So what's the 401st going to be? Cosine, and the 402nd, negative sine. Not too bad, huh? Well, I mean, yeah, if I said find the 402nd derivative of, x times sine of x, then that would be, more difficult. So there's a pattern. Okay, we flip it over. There's some anger from second hour when we got to this stuff. No, they're not an angry group of people. They just got angry. Yeah, they were you're right. Oh, Luke, one day you're just going to go to the office. All right. First and second derivative, C, f prime of x. Okay, I'm going to set up the boxes here so we don't get lost. What's U? What's the inside? What's the outside? I hope that at this point you've memorized the derivative of u to the 1/2. You don't have to think it through. One over 2 roots of u. Okay. You wrote 1/2 u to the negative 1/2. That's fine, but then, the square root just comes to the denominator. So, and then the derivative 2x minus 3, 2. Multiply them, and you just have 1 over the root of u, correct? or 1 over the root of 2x minus 3. Now I need to take the derivative of that. (2x minus 3 to the negative 1/2). Correct. Don't use the quotient rule in that situation. Yeah. What here's another scenario where I've seen people, they're starting to use the quotient rule. Don't do this. 4 over the cosine of x. Don't use the quotient rule. How should you write this? 4 times 1 over cosine is the same as no secant. I mean, just take the derivative of 4 secant instead of using the quotient rule for 4 over cosine. But you got to remember your trig if you're going to do that. I promise you have to know stuff like that for the test. You got to be able to have your wits about you. Okay. All right. So the inside is 2x minus 3, and the outside, you already said, is u to the negative 1/2 this time. Derivative of 2x minus 3, 2, and derivative of u to the negative 1/2. Negative 3/2. So if you multiply those, the 1/2 goes away. The negative 1, and we'll drop the negative exponent to the denominator. 2x minus 3 to the 3/2 then. I've seen in your book that there's a couple times they've left answers with negative exponents. Do not do that. I don't know why that happened, but I would say that that's not acceptable. No, if you put it as a square root, then you're going to have to reduce it because you would have a perfect square you could take out because it would be cubed. So don't do that. Yeah, but if you do that, if you do negative 1 over 2x minus 3 to the 3rd power square root, you have a perfect square you could take out. Technically, this should be simplified to negative 1 over 2x minus 3 times the square root then of 2x minus 3. Technically, you shouldn't be leaving it like that. You should write it like that. So just go ahead and leave the rational exponent. Okay. All right. We'll have time to do the first derivative here. We'll do the second derivative when you get back. That could be in a better mood anyway. So, okay. So, no, get out of here. All right. F prime of theta. What rule do I have to use? Product rule. Again, on the test, I'm not going to tell you if you use the product rule, chain rule, anything like that. You got to know what rule to use when. So, derivative of theta, 1 times the second part, I have cosecant of theta. Plus negative cosecant theta cotangent theta. Good job. Times theta. It's really tough when people write the times theta on the end there. Put it in front. That way we're not confused if it should be like a theta squared or something like that. So this answer is cosecant of theta minus theta cosecant of theta cotangent of theta. That's the first derivative. So that we can anticipate, if I take the second derivative, what do I have to do? Product rule how many times? Twice. If you can leave it like this or take out a cosecant, either one would be acceptable. But when you take this derivative, you're going to have to treat this as f. You're going to have to treat this as g and use the product rule. And when you find the derivative of f, you'll also have to use the product rule. So when we get back, we'll do a double product rule. We'll get that done. Eat some good food. Fill your tummies.